Hey guys, Mr. Gran here, and this is a combination for 3, 4, and 5 triangle congruence theorems. So in this video, we're going to learn about what the different triangle congruence theorems are. All right, so you maybe have had a math teacher talk about how like triangles might be their favorite shape, right? Or maybe triangles are a very special shape. Triangles are really special, and the reason is that they're what we call like a rigid shape, meaning that, let's say I take something that's not a triangle, right? This square, okay? So it's a square made of 4 pencils. I can make a bunch of other shapes with these 4 pencils, right? I can take this and I can distort it. I can make it into a parallelogram or a rhombus. Like I can change the angles without changing the side length. So this isn't a rigid shape, right? It's got some flexibility to it. With a triangle, it's not like that though. Every triangle that has the same length sides, these 3 length sides, I can only make one triangle with it because I can't like actually change this shape unless I either like detach one of these or I break one of the sides or I shorten one of the sides. This is completely rigid. It can't change other than like breaking the joints where they come together or breaking the sides and changing the sides themselves. So I know if I have like these same 3 pencils and I put them back together, it's going to make the exact same triangle every single time. This is why in like things like bridge framing, right? If you look at these, this is the Winona Bridge in Winona, Minnesota. And if you look at this, steel bridges and a lot of other things that in framework, they make a lot of triangles for that exact reason, because the only way I can change the shape of that triangle is either if I break the actual beam or I break one of the connecting points. I can't like bend it at the corners like if I had like a square piece, right? Like if I had a rectangular piece. So that's why if there's usually a rectangular section of framing, they put a piece that goes corner to corner, and that keeps it from being able to distort like that. Okay, so what is the consequence of that mathematically? Well, that means for triangle congruence, we don't really need to know that all 3 sides and all 3 angles are the same in order to know everything is congruent, right? There's 5 different ways that we can prove that 2 triangles are congruent without knowing every piece of information about both triangles. All right, so one of them is side, 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 right? If I know that I've got the 3 sides that are pencils, right, I can only make one triangle. So if I take 3 other pencils that are the exact same length and I make another triangle, it's going to be the exact same triangle, right? So SSS, this means side, side, side. Looking at this diagram, I've got these 2 sides are congruent, these 2 sides are congruent, these 2 sides are congruent. That's enough to say that these 2 triangles are congruent. The next one is side angle side, right? So if I know that 2 sides and the angle in between them are congruent, I also know that those 2 triangles are congruent. So I've got 2 congruent sides, right? Another set of 2 congruent sides and the angle in between them. Now order kind of matters here. So when we're looking at these diagrams, we should be like picking a place to start and then moving around the triangle around the outside. So I've got a side here. I've got the angle here, right, for this corner, and then the side. And if I go in order, it's side, angle, side. We can also do angle, side, angle. Right, so if I've got 2 sets of angles and I've got the side in between them, I know that those two triangles are congruent. And again, think about the order here. I've got an angle here, I've got a side here, and I've got an angle here, and everything is in order. There's not like another side in between or anything like that, or another angle in between. It's in order, angle, side, angle. We can also do angle, angle, side. right? So if I have two angles and the side that's not in between them, one of the sides not in between them, so like these two congruent angles, two congruent angles, two congruent sides, and the order of them, it's an angle, then a side, right? Where I've got an angle, the next angle, and one of the sides connected to it. That's angle, angle, side. And then the last one, this is a special one. HL, what this stands for is hypotenuse leg. Right? This is only in right triangles. This is the only time that this works. It has to be a right triangle in order to have a hypotenuse, so that's the only one that works. So we've got our hypotenuse, and we've got one of the legs. It's a right triangle. That means that these two are congruent, right? They're both 90-degree triangles, so I have an angle for both of them, a special angle, a right angle. I've got the hypotenuses, the hypoteni. They are congruent, and then I also have one of the legs is congruent, or two of the legs are congruent. All right, some theorems that don't show congruence. I guess they're not really theorems because they don't show congruence. These ones don't work. Angle, angle, angle does not work, right? It makes a similar triangle. They're proportionally the same, but their sizes aren't necessarily the same. So angle, angle, angle is not one. So like this would be an equilateral triangle, right? The one I made out of pencils. But if I connected two pencils and made a bigger one, right, the angles would be the same, but the triangles would not. That's the idea. That's why angle, angle, angle doesn't work. Also, side, side angle does not work. So we've got two sides, right, that are congruent, and we've got two angles that are congruent, but it's not the angle in between, right? So if I go side, and then a side, and then an angle, like that doesn't work. The angle has to be in between the two sides. And this is an example of that where we don't know what the top angle is or the bottom angle is. There are more ways that that triangle could be put together. There's actually two options in that case for these two matching sides and a 45-degree angle.